Today, we are looking at something truly incredible, a new scientific paper that details a groundbreaking way to tackle two of our planet's biggest problems at the exact same time. So, what if I told you we could take plastic trash, old bottles, and use it to make fresh, clean drinking water using nothing but the power of the sun? Yeah, it sounds like science fiction, but it's very real. Let's get into how it works.
So let's just start with that huge question right up front. Can something like plastic waste actually be a part of the solution for water scarcity? It's a bold claim, for sure, but the researchers behind this new study are showing that the answer is yes.
All right, first, let's just quickly set the stage. Problem number one, we are, and this is not an exaggeration, drowning in plastic. Projections show that by the end of this century, the amount of plastic waste on land could almost double, and in our oceans, it can multiply by 5. It is a massive, and I mean massive, global challenge.
And at the very same time, we've got problem number two, a parallel crisis, the lack of fresh, clean water. With populations growing and pollution getting worse, just finding safe drinking water is a huge, ongoing struggle for people all around the world. So you've got these two gigantic problems that seem totally separate.
But what if they aren't separate at all? What if the key to solving one problem is actually hiding inside the other? This is where things get really, really clever. It's all about reframing how we see the problem in the first place.
And this quote from the paper really nails the core idea. It's about a huge mindset shift, right? Moving away from our old model of take, make, and throw away to a new one where, waste doesn't really exist. It just becomes the raw material for the next really valuable thing. And this research is a perfect example of that idea in action.
Okay, so how in the world do you actually turn an old plastic bottle into a high-tech water purifier? Let's break down the science of how they create this amazing new material.
So it all happens in 3 main steps. Step 1 is carbonization. They take everyday PET plastic, think soda bottles, and they pyrolyze it. Now that's just a fancy word for baking it at super high temperatures without any oxygen. This turns the plastic into this black, spongy material called carbon foam. Step 2 is synthesis. They take that foam and mix it into a water-based solution with some copper and sulfur. And finally, step 3. Decoration. They gently heat that mixture up, and that causes these teeny tiny, microscopic copper sulfide nanoflakes to literally grow all over the surface of the foam.
In this diagram here, it shows you that whole journey. You can see on the left, you start with plastic bottles. They get transformed chemically. Then, through this hydrothermal process, which just uses heated water, they become the final product you see on the right, a photothermal layer. And all that means is, it's a material that's been specifically designed to absorb light and turn it into heat. It's kind of like alchemy for the 21st century.
Okay, so now we have this new material, but what exactly makes it so special? How does it actually do its job? Well, the secret is in how its 2 main parts work together. You can think of it like a solar sponge. It's really a perfect partnership, a dream team. First, you've got the carbon foam, which is made from the plastic that acts as the sponge. It's incredibly porous, so it can wick water up really effectively, and it's also a fantastic insulator, which is key for keeping the heat from escaping. And then you have the copper sulfide nanoflakes. These are the heat magnets. These little flakes are just unbelievably good at soaking up sunlight and turning that light energy directly into heat.
And when you zoom way in with a microscope, you can see what's going on. On the left, that's the porous, spongy structure of the carbon foam. But then look at the right. You can see how it's completely blanketed in those super thin copper sulfide flakes, our little heat magnets. It's this 1-2 punch of a spongy structure and a massive heat-absorbing surface that really makes the whole system work.
So just how good are those heat magnets? Get this, the final material absorbs over 95% of the solar energy that hits it, and that's across the entire spectrum of light. It's basically a black hole for sunlight. It just soaks it all up.
Now, of course, having great specs in a lab is one thing. But the real question is, does it actually work? Can it desalinate water effectively? Let's check out the results and see how this thing performed when they put it to the test.
Whoa! This thermal imaging is pretty dramatic. It shows you just how fast the surface heats up when you put it under a simulated sun. So that top row is our new material. It goes from room temperature to over 75 degrees Celsius. That's about 167 degrees Fahrenheit in only 10 minutes. I mean, it gets hot, and it gets hot fast.
But okay, does all that heat actually lead to more evaporation? The answer is a huge yes.
This chart shows you the magic of that dream team. See, the carbon foam by itself is pretty good, and the copper sulfide by itself is okay. But look what happens when you combine them. The performance just shoots way up. The whole is truly, truly greater than the sum of its parts here.
And it all adds up to this final, really impressive number, an overall water evaporation efficiency of 91%. So what that means is that 91% of the solar energy that the material absorbs is being put to work turning saltwater into freshwater vapor, which you can then collect. That is incredibly efficient.
So what's the big picture here? What does this all mean? Well, this is way more than just one cool material. This whole research project gives us a powerful new blueprint for how we can solve problems in the 21st century.
It all comes back to this amazing idea of a circular economy. Instead of just, taking resources from the earth and creating waste at the end, this process takes that waste and turns it into a vital resource. It is a perfect real-world example of how we can close the loop on plastic pollution.
And just to put this into perspective, this table here compares our new plastic-based material to a bunch of other really advanced technologies. And as you can see, it doesn't just compete with them, it blows a lot of them out of the water. It performs significantly better, and remember, it's doing this using something we literally throw away every single day.
So the big takeaway here is that we can design systems that solve multiple, massive problems all at once. This is such a breakthrough because it's using cheap, superabundant plastic waste to create this high-performance system that is totally solar-powered. That means it could work off-grid in remote places where clean water is needed the most.
And that just leaves us with this final, really exciting thought. If we can turn old plastic bottles into fresh water generators, what's next? What other things that we call waste right now are just sitting there waiting for the right scientific breakthrough to unlock their incredible hidden potential? That's a question that could really redefine our future.